Good afternoon, good morning, good evening, wherever you are. Welcome to this WorldCereal webinar. We are giving participants just a few more minutes to join this webinar, so stay tuned. We will begin shortly. If you have any technical issues, just write us a chat. We will try to help out. The chat is not for Q&A. We have a separate Q&A for that. But if you have technical issues, definitely let us know. Okay, welcome once again to this WorldCereal webinar. If participants are joining later, that's fine. The webinar is also recorded, so every registered participant will get a recording afterwards. My name is Christophe van Tricht. I work at Vito in Belgium. I am project lead of the ESA WorldCereal project. And it's my pleasure today to introduce two speakers. I'll first give a setting of the scene. Where are we today with WorldCereal? And afterwards, we will have two dedicated speakers. So again, if you have technical issues, you can use the chat to get in touch. Use the Q&A, though, if you have any questions, which we will handle either from the Q&A tab, or we will discuss them live at the end. There is a specific Q&A session foreseen at the end, so we will tackle your questions. Okay, so the agenda for today, I will briefly give an update on where we are with the project, and then also introduce you to a few challenges that we have to tackle to scale up WorldCereal for the next global round of WorldCereal maps. Then we will have a presentation by Italo Moleto Lobos from University of Valencia on the WorldCereal Global Crop Calendars V2. And we will have a presentation by Lucille Yam on using existing crop type maps to overcome reference data scarcity. I will end with some conclusions and an outlook from a project basis, and then we will have the Q&A session. So first things first, where are we today? It's important to keep stressing that WorldCereal is not only a product, but a processing system. It takes care end-to-end of all factors involved in crop type mapping. That is from the processing of field data, acquisition of overlapping satellite time series, the training of crop mapping algorithms, and finally, also the production of the actual maps. By default, the system is running on a cloud base running on the Copernicus data space ecosystem and driven by the OpenAO API. It means that you don't have to install or process anything locally. A while ago, we focused significantly on the classification algorithm in itself. And just to give you a few updates on that, as you may know by now, WorldCereal operationally deploys the NASA Harvest Presto model, which is one of the first pre-trained geospatial foundation models. And we deploy Presto operationally to summarize all the satellite time series and other inputs that the system uses into 128-dimensional vector. This is the so-called embeddings where there's so much to do about lately. These embeddings are then the basis for classifying crops in your region, both for us on a global scale, but also for you on a local scale. And you can benefit that way from what has been learned already in the past and on a global scale and train a downstream model based on your own data. Because we see that there's so much interest in these embeddings, we recently released like a byproduct WorldCereal workflow, which lets you export the embeddings themselves. So you no longer have to produce a cropland map or a crop type map. You can actually now also look at the embeddings themselves. And contrarily to many existing algorithms and systems, they will be computed on the fly on a spatial AOI of your choice, and especially also on a time of interest of your choice. You're not bound to a calendar year. You can basically pick whatever positioning of the year as you like and explore the value of these embeddings. We used we benchmarked a lot the use of a pre-trained model like Presto for something like crop type mapping in WorldCereal. And we recently had our paper published in the proceedings of the Terabytes workshop. And so we demonstrated how you can operationally deploy a geospatial foundation model. And so we published a structured approach for remote sensing practitioners to integrate geospatial foundation models into operational mapping systems. If you, just like us, are looking into using geospatial foundation models for a mapping application, then it could definitely be an interesting read. Another aspect we have been working on is the scalability of our crop mapping solution, not only because we needed to produce crop type maps at the global scale, but especially also because our users were requesting it. So we worked a lot on the efficiency of our workflows. It has been increased, and thereby it lowers the processing time, but especially also the processing costs. We've demonstrated this ourselves already in numerous large-scale crop type maps. CDSE still offers you 10,000 free processing credits each month. If it's not enough, then there is at least the ESA network of resources where you can request funding for additional processing credits or get in touch with us. There's numerous other ways to get extra processing credits, and soon there will be also a more convenient way to actually purchase processing credits to use them on CDSE. The next point of attention, now that we have an operational system in place, we move towards the actual applications and user uptake. This can go from relatively straightforward applications in regions with dense training data, like this 2025 crop type map that we produced for France, but also in more data scarce regions. We did successful tests of the system, for example, here in Brazil, where we generated a crop map for 2 years, for 2022 and for 2024. And if we look at the difference, then we clearly see expansion of cropland area in 4 years' time. This is just one example of how WorldCereal can be used to monitor, for example, deforestation in favor of cropland expansion. Within the context of the project, we are working with 3 partners on regional use cases to demonstrate the added value of the WorldCereal system and products for downstream applications. The use cases include crop type mapping for wheat yield estimation in Brazil. This is together with CONAP and INPI. And our partner University of Valencia will be evaluating the impact and the added value of high resolution crop type maps on a low resolution crop yield estimation model ARIA. Another use case is assessing the ability of the WorldCereal system to map crops in a smallholder farming context. And here we partner up with CIMMYT, which is organizing field data campaigns in Malawi, Zambia, and Zimbabwe mainly. And the third use case will assess the benefit of having accurate and local in situ reference data on the quality of crop maps in collaboration with Varaha, a commercial company providing services to smallholder farmers in India. And these are just a few pictures of one of the first official use case that we did within WorldCereal. So this is the one together with CIMMYT, where in Zambia we recently had our first local use case taking place there, where we discussed and trained the people and the institutes to work with the WorldCereal system and jointly learn how to move things forward. Next to the 3 use cases, we also organize numerous technical trainings for a variety of institutes that are exploring the potential of WorldCereal in their own lines of work. Through these trainings, we not only build capacity and spark curiosity to test out a system for true food security scenarios, but we also collect valuable feedback that helps us further improve the system. And this is just the first step while we move forward. And then finally, WorldCereal doesn't stop with its predefined requirements. For example, while currently the official WorldCereal system is an end-of-season crop type mapping tool, we recently also engaged with the Joint Research Centre of the European Commission in a pilot study to adapt the WorldCereal algorithms for in-season mapping purposes. And this led to an in-season French crop type map produced in June already this year, and it's formed the basis for GRC's Agri-Forecast Mars Bulletin, just to show that also a lot of downstream projects and research can be done that builds upon what we have been doing in WorldCereal. So while our capacity building activities will continue, it's now time to focus again on that other big promise of WorldCereal, which is a next round of global production of WorldCereal maps. This is an even more ambitious undertaking than the 2021 maps, which still focused on maize and cereals, wheat, barley, and rye only. We now aim to produce global maps with up to 11 classes, including new major crops such as soybean, sorghum, sunflower, and rapeseed. And so, in the brief overview so far, two important ingredients that we need for producing these global maps were already touched upon: robust classification algorithms on the one hand, and a scalable infrastructure on the other hand. But let's talk about two other crucial ingredients that could make or break our global maps, and which we'll dive into a bit deeper today. Absolutely crucial is as much training data as we can get. Even with today's pre-trained and robust algorithms, like with Presto, local training data still greatly improves the quality of local maps. We have therefore spent enormous efforts in the past few years collecting as much existing reference data as possible, spread in space and time. Still, however, large spatial gaps remain, which will challenge the extrapolation capabilities of our models. One solution for this problem led us to existing high quality and openly available crop type maps, and later in this webinar, we will tell you how. But let's first talk about the seasonal nature of WorldCereal. Crops don't limit themselves to calendar years, and multiple cropping seasons over the course of 1 year may be a rule rather than an exception. With time-explicit embeddings extracted by Presto, we are able to focus on different parts of a year of satellite data with even just one forward pass of a model. The prerequisite, though, is that we know which parts of the year to focus on, and these are the cropping seasons. And while local experts most likely have the best knowledge on growing seasons in their region, for our global WorldCereal maps, we need a consistent best estimate on crop calendars at a global scale. And so our next presenter, Italo Moleto from the University of Valencia, has the full story on the new version of the WorldCereal crop calendars. Italo, floor is yours.
Thank you very much, Christoph. So, yes, now I want to present you how now we enhance the global crop calendars in the WorldCereal system. For that, we need to go further, understand basically what is a crop calendar. In super simple terms, the crop calendar is an agricultural tool that schedules the key farming activities, such as the planting date, the fertilization, the irrigation schedules, and as well the harvest. So with that, we can know the timing when start the planting and the season. That this is key parameter for the WorldCereal system. So now, how are obtained traditionally the crop calendars? Basically, from the agricultural surveys and expert reports of the different institutions that can provide information, such as FAO, USDA, or GeoGland Crop Monitor, or GRC. So here, for instance, we can see in the image of the top the product of the USDA FAS. They basically show here in Brazil what are the timing of the crops of the different plants. And as well, in the below, you can see the GeoGland Crop Monitor, how they see the dashboard that is available of the different moment, if there is the developing of the plant, if it is growing or is harvesting, etc. And as well, this information can be used for provide different models. So there is models that are mostly based on climate datasets, such as the work of Maeve Sachs and as well French and company that use these surveys and provide, based on the climate parameters, especially explicit evolution of the different crop calendars across the different areas. And as well, technologies such as remote sensing can provide metrics that is related to crop calendars, such as land surface phenology. But basically, based on the signal that retrieve the satellites, like for instance, NDVI, like the greenness, you can see the evolution of the plant, and you can detect based on different thresholds when it starts to grow, and as well how it's end the season. In the case of the remote sensing, we need to consider it that in difference that the planting date, you can see when the plant started to be shown by the signal. And here you can see an example of the CLMS that you can see the different land surface retrieval parameters. Here is not just for crops, but across the whole world. So it's important to combine the parameters to have a good product. In the past, we can saw that there is different products that of the statistic crop calendars that are very good. However, there are no especially contiguous. So at some national level, you can see the same day. So this is a room for improvement of these different calendars for ingest in a system that need remote sensing and dynamic dataset. And as well, this have been developed in the first phase, but however, in that moment, the product was relied just in two kind of crops, just the winter wheat and maize. And in the winter wheat, the dormancy wheat not addressed in the products. So in this gap of information that we need to do now we are started to update this whole product to ingest in WorldCereal system that now has 11 different crops. So for that, we aggregated those different crops in two big groups that have similar scheduling, such as summer crops as winter crops, and as well addressing now the dormancy that is required for the different winter crops. So how we did that? Basically, first of all, we took all reference dataset, georeferenced across the world. We trained it with climate data from era 5, from the air temperature, the precipitation, and dew points. And with that, we made a simple machine learning model based on XGBoost to get a contiguous, especially contiguous across the whole world of the different crop calendars for winter crops and summer crops. But since the all parameters, all reference data is not enough for have a global coverage and representativeness, we added the WorldCereal temporary growth percentage model. We aggregated at 5 kilometers, and we incorporated as well the coarse resolution NDVI MODIS for retrieve the land surface parameter based on these dates available from the first iteration of the global products. With that, we retrieve a global parameterization of land surface phenology of the different products with the purpose of increase the training dataset and have a global coverage and densified dataset of start of season and end of season, the crop calendars across the world. So we reiterated again with new ground data parameter dataset, and we modeled it again with the XGBoost model to have an improved product of the crop calendars and having a global coverage in each terrestrial surface. With that, we increased more than 100% of dataset and have it a densified product. However, we need to know how is the uncertainty of the product. So we validated as well with three strategies. The first one was the XGBoost, basically taking different metrics of validation. And as well, we asked it to different expert external validation. How is the performance of the product? In INPE in Brazil, NASA Harvest India and Kenya, the Chinese Academy of Science in China, and Foreign Acre Fund for Burundi, Rwanda, and Malawi. And as well, we compare the global crop calendars with completely external dataset retrieved for Catarina Waha. These are different surveys across 4 countries of Africa. We retrieved this all information. We aggregated at the resolution of the global crop calendars and compare with the different metrics. So the key results here in the product we see in the following. First of all, in the first iteration of the product, basically just using the reference dataset and era 5 products, We have a good performance mostly in products, except by the summer crops end of season that we have a high uncertainties. But there is still room for improvement. We need to consider that the reference dataset are monthly resolution. So we're now adding the second iteration of the product using the land surface phenology parameters. We can see that the performance in, increases steadily with error square over 0.9 and having below 1 month of error. So there was a good improvement, especially in the summer crop end of season that was not getting the requirements of having adequate products. And as well, when we make a zoom and we see the time series now of the product, we can see here two examples of two continents, one for summer crops. And we can see now in the summer crops of the smoothed NDVI dataset, we can see different clear seasonality bits across the countries, and we see coherency with the signal of NDVI. And as well now in the winter crops, now here I made an example of Europe, since they have several countries with dormancy. So we can see now the dormancy dips. So you can see in the evolution of the different countries. As well, when we ask to the different expert institutions, he sees the example of China. We say now in Tibet, they have some biases of the modelation of the product. So we re-ingested and reiterated the product, and as well in this part of China. So we get more consistency in those areas that didn't have it, improving it with the different validation of expert, re-ingesting the dataset and remodelating again. And as well, after all of that, comparing with external dataset validation of Catarina Baja, we can see here comparison with 4 countries, Malawi, Mali, Niger, and Nigeria, aggregated at the resolution of the global crop calendars, and comparing with the product, we have 1 month of error overall for all dataset. That is, I repeat again, the resolution of the product of the we ingested this dataset. So we can see here that it's important to have ground truth data that can compare independently, because can show how is the performance of the products. So in conclusion, we can see that now giving a second iteration in these global crop calendars, integrating the land surface phenology and giving a talk with the machine learning, we can have an error square over 0.9. We can address the challenges that we're facing before in the first phase, that was the dormancy period. We increased the dataset densified using the remote sensing data, and this is allowed to us to have a pixel-based seasonal monitoring that can be used for different food security applications, such as World Cereal System by itself, personal usage, and yield forecasting, or any other needs that are required. And as well, this product has validated for different expert institutions. This paper was being uploaded and submitted to Ecological Informatics as now currently is under review. So we expect soon to have it available to download for anyone and check the paper. But in the meantime, there is the preprint that is available, so you can have it a look as well. Check out where in deep, how is the methodology, and as well explore the dataset, etc. And of course, all the dataset is available. So here do you have a link, you can have a look. You can have as well the scan with the QR code with the cell phone. And address how is the global crop calendars of the product. Basically are 4 tips that you can see here, and you can download it. As well, this product has been integrated in World Cereal Classification System, as you can see. And of course, we can give it a look of the data. We can use it. And as well, you can share your feedback. So as well, I leave you my contact. Here is my name, Italo Moletto, UV.S from University of Valencia. So now I'm gonna share you a little example of the in QIS, how it can be worked. So if I share the screen again, but now I will go to QIS. Boom. So of course, for technical users that are using JS, this is available, and as well, this is a free software that can be used for anyone. And here, of course, this is for dataset. We have the season one, that is the equivalent of the winter crops that I showed in the presentation. Here, see the naming, the season one, season two. SAOS is start of season, and AOS is end of season. So we can see here a raster, a continuous dataset that can be showing DOI, day of the year. So we can give it an explore. Of course, we can give it a color palette. There is several color palettes in the software that you can apply. Or as well, you can load a style that could be fit better for a continuous dataset, a cyclic dataset, such as the day of the year. So here in style, for instance, we can load a style and check the product. And this is the DOI palette. This is it will be available soon as well in the Synodo. And you can see the colors of the product and day of the year. So what that it means, this map of colors? Basically, we can make a click. They say the day of the year, the start of season on the different crops across the world. So this is the product that the WorldCereal can ingest, and as you as user as well can apply it. Typical example, for instance, to retrieve that information is just applying statistical sonification. So a typical thing that you can do in QAS is right here in the bottom, is write world. And if you write world, you can load the world map layer. So in the processing toolbox, we can do some certain statistic, very basic for applying. So you can let any layer, any shapefile. Here's the world map. So they say this is the polygon layer that you can work. And the raster layer, for instance, you can use the start of season of the product. And here you can see the statistics to calculate. For instance, we can calculate the average, the median of the product, the standard deviation, the minimum, maximum, and the different statistics that you can use as well. So you just give it an OK. We're just running on a temporary layer as well. You can save it here to save it to a file or different format as you wish. And we just give it a run. So what pretty quick. Basically now we have two layers. I mean, we have the raster as well, the world map, and produced a new layer that's called the zonal statistics. And if we go in right click and we see the attribute table, that the metadata that have been retrieved, now we can see all the name of the countries that is available on the layer world map, and as well the value of different products. So we can see the average value that can be in the day of the year. So you need to traduce this as well. The median, the standard deviation, the variability of different products, the minimum, maximum. Just be considered that they need to handle carefully in some cases, like here in Russia, when do you have difference of data because the day of the year one is the 1st of January and the last values are nearby December. So in these cases, you need to consider that there is a circularity of the product by itself. But for insight, you can have it very easily and very quickly, very simple parameterization of the product. So this is just in most general terms how is the crop calendars product. You can give it a look, and as well, feedback is pretty welcome. So this is from my side. I will answer in as well the question. This is available in the chat. Give it the floor again to Christoph to continue.
Thank you, Italo. Unfortunately, the very last part of the demo, it seemed that the screen was frozen, but it was when you clicked open attribute table. So I think
Okay.
if people follow it to that point, it will be fine. So it's okay. Like
But
this
maybe
is
because it
fine.
was part of parameterization of the of the Zoom. My apologies. Here we can be seen, right?
Yes.
Of course, yeah. That was I meaning that basically here you just retrieve the different statistic of the product. So basically, you can see the mean, the median, standard deviation, minimum, maximum. That was the part of the I said. So yeah,
Okay,
that was basically.
perfect. Thank you, Italo. Okay, so just to also mention briefly that indeed, let me put this here correctly, that indeed, besides it's now an external data source that Italo showed, these crop calendars are as such embedded, of course, into the WorldCereal system. And most of our workflows will ask you to specify an area of interest for your analysis, and you will be presented with the two major growing seasons for that area based on the WorldCereal crop calendars, as Italo has just mentioned them. You can use this information, for example, to temporarily constrain the existing public reference data in this area so that you can match, for example, in this case, the training data with your season of interest. So if you would pick or be interested in season one, then only the reference data in your area of interest that matches that growing season would be retained for model training. Of course, as said before, if you're a local expert, a local agronomist, your definition of a growing season can be much more precise. So you are always able to override this seasonality to the best of your knowledge. But our best estimate in any region in the world is now covered by this new version of the global crop calendars. Okay, so time now to move on to the second dedicated presentation of today by Lucille Jam. Lucille is an applied mathematics student at Polytechnique Sofia in France, and she recently completed an internship at the European Space Agency. We were really honored to have her as part of the WorldCereal team. And Lucille really did some amazing work on addressing the spatial gap that I mentioned in our global scale training data. Today, she will walk us through the procedure of sampling data, training data from existing crop type maps to address these spatial gaps. Lucille, the floor is entirely yours.
Thank you very much, Christoph. So during my internship at the European Space Agency, I had the opportunity to work with the WorldCereal team on how to use existing crop type maps to overcome reference data scarcity. So accurate crop type mapping relies on high quality reference data for model training, but in situ observations are limited, expensive to collect, and unevenly distributed across the globe. So in the map below, you can see that many key agricultural regions, especially in the global south, still lack sufficient labeled data. So the question becomes, how can we extend crop type mapping to these data scarce regions? And one option is to make use of existing crop maps as long as we understand their quality. So to build a reliable training dataset, we first compiled existing crop type maps. We identified 59 different sources across Asia, Americas, and Africa. And the dataset mainly came from scientific publications, official websites like space agencies, governments, but in some cases, we also directly contacted authors. So unfortunately, not every dataset could be used. We had to apply selection criteria to keep only maps that were useful and trustworthy. So we mainly looked at the spatial resolution, the geographic and temporal coverage, proper documentation, year references, seasonality, clear class definitions. We also wanted to select the higher accuracy as possible, classes with highest accuracy. Also, if available, a pixel level confidence was also preferred. And of course, the license must allow reuse and derivative work. So after applying these filters, we retained the best material to create high confidence training data. In some region, we had several crop type maps for the same crop and season. For example, here we had 5 winter wheat maps in China. So we overlapped all maps and simply counted how many of them agreed at each pixels. And where all maps agree, we can be very confident that this is really winter wheat. So we only kept the intersection to be the high confidence sampling layer and to discard less reliable pixels. So to extract reliable training samples, we applied a sampling methodology. We first splitted the crop map into H3 cells, which is a hierarchical hexagon grid developed by Uber. This is very useful here because it's hierarchical, so we have different sizes that we can adapt to the region and also to the map resolution. So the first step was to filter out classes with low user accuracy. So then we could erode some field boundaries to avoid mixed pixels and mislabeling at the edges. And within each cell, we fixed a number of samples to select. And preferably, we wanted to select the most confident pixels if the confidence layer was available. So we would avoid spatial clustering and keep the samples well distributed. And this gives us high quality and spatially balanced training points. So in total, we processed 113 maps after applying this sampling workflow across 17 countries, and it resulted in 67 datasets. So here in the map, you can see the differences between before and all the points we added. And they also cover the most major crop like soybeans, maize, rice, and winter wheat, for example. So to evaluate the usefulness of map-based samples, we focused on Argentina. It's a perfect test case because we have sufficient high-quality reference data for validation, also several multi-year crop type maps. The main growing season also aligned well across all datasets. Here it was summer. And so we assembled 4 datasets to represent different real-world training scenarios. So we had our map-derived labels with a medium quality with a lot of samples. Also true in situ field data with a high quality and less samples. We also wanted to try with European high quality samples to test the cross-region performance of the model. And we also kept high quality hold of only for evaluations. So the idea is to mix and compare these data sets to understand how much map-based data can replace in situ data. So here we compare different training data sources evaluated on the same high quality test set from Argentina. And as expected, local in situ data performs better overall with a F1 of 0.85 for maize and 0.76 for soybean. And when training only on European samples, so from a completely different region, performance drops significantly. But we also observe that adding in situ to map-based samples have a very good performance, especially on maize. It's almost cross the upper baseline that we stated before. And that all map-based samples are maybe not enough. So here we show visual comparison of it on a test site in Argentina. So only using data from Europe performs poorly because of the model doesn't transfer well across regions. And training only on map-based samples give noisy results, but are still okay. But prediction are especially noisy around field boundaries and in more complex fields. We get cleaner results with only in situ or in situ map-based samples. So here we gradually replace map-based samples with in situ samples and observe the impact on model performance. So when we have at the left 0% of in situ data, the accuracy is less good, but when we only add a few proportion of in situ data, the quality is way higher, and we reached the upper baseline. So high quality observation can unlock the full value of map-based data. And map-based labels don't replace in situ data, but they strongly reduce the need for it. So this means we could reduce field data collection efforts while still achieving a good accuracy. So if any of you is a map producers, these points may be particularly useful. So first, clear licensing and open access for the community can really help to use your products. And per class user accuracy and good metadata on class definition really helps understand which crop we can trust and where. And specifying exact year and season of the map is also essential, especially in multi-cropping region. And including pixel level confidence layer is also a plus for us, because we can then know which regions, which areas are most trustworthy for training. So transparent documentation can make high quality maps more valuable for global applications. And for users who want to take advantage of existing crop maps as training data, here are a few best practices. So first, we avoid map-only training because we have a lot of samples, but there is a risk of overfitting, and we may not capturing challenging fields. Then combining map-derived samples with a small proportion of local in-situ samples can really help improve the performance, as we saw before. Also, always validate with independent high-quality reference data is essential to observe how efficient is our model in real life. And always be cautious with domain transfer, cross-region, and cross-field differences, because we can see that the performance can really drop. So the key sentence here is that map-based labels can strongly boost trainings, but quality still matters.
Thank you, Lucille. Great presentation. If you have questions for Lucille, don't hesitate to put them into the Q&A. We've got a few questions already in direct messages to us, so please, if you can just repost these questions in the Q&A tab, then also others can see these questions, and it's easier for us to answer them at the end. So if you have sent us these questions directly, and if you could just repost them in the Q&A, that would be great. Okay, that brings us to the wrap up for today. So some conclusions and outlook so far, because the official WorldCereal project still runs for about a year from now. We'd like to keep stressing always, both in the beginning and at the end of each presentation, that WorldCereal is not just a product. It's truly an ecosystem of resources and tools that jointly aim to bring crop type mapping to any possible user, from a researcher at the university or in a large scale institute. No matter who, we want to bring these tools and all this knowledge and data really to everyone's hands. You can consult and use the existing maps from phase 1 and at the end of next year, hopefully also from phase 2 with all the new crops. You can consult, download, use within the system, or even export the public reference data that we have collected that were generously shared with us and harmonized by us, and also the new crop calendars. Or you can go the next mile and generate your own custom crop type maps by using the public available data. Optionally, add your own private data that will be harmonized automatically as well. We have dedicated resources if you want to find out how and produce your own crop type maps fully on the cloud without the need to install anything. And throughout this entire journey, there's really a range of entry points to find documentation, to find demonstrations, usually in the shape of Jupyter notebooks, ask questions on the forum, ask questions to us directly, or seek any kind of support. So we offer tool entry points for a variety of skill levels, ranging from just point and click interfaces using our processing hub. It has the ability to run the default crop type maps from WorldCereal or custom crop type maps if you provide a URL, which is something that you can generate by following one of our custom crop type generation demo notebooks. The rest of the flexibility requires a little bit more advanced tooling. So for that, you can go to Jupyter notebooks or even command line interfaces that we expose through our open source repository on GitHub. Choose whatever serves you best and let us know if anything is missing. We're happy to accommodate for that. Finally, we'd also like to mention that there's a few upcoming opportunities to be involved besides additional massive online courses that we are going to release, for example, on the system and the algorithms themselves. The webinars that we are doing, videos that we post on WorldCereal or updates on LinkedIn. We also have some dedicated trainings that we set up in collaboration with external partners. These training events are usually open to external participants. There is no funding whatsoever to accommodate for travel. We at least partially try to provide virtual participation if possible. But in all of these, we definitely want to be as open as possible to accommodate for any kind of interest of anyone to participate in any of more of these trainings. So all of these will be announced through our newsletter on our socials on LinkedIn. So it's definitely best if you already see one of these upcoming in-person training events that you might be interested in, to just reach out through us via the website, fill in the contact form, send us an email if you are interested, and then we can see what is possible there. Okay, that brings us to the last part, which is the Q&A session. So really, the message here is to give it a try. We have these multiple entry points for you to pursue, the crop calendars to investigate and to provide feedback on if you like. So documentation, support our forum, it's all there. Subscribe to our mailing list and you'll be the first to hear about any of our updates. With that, I'd like to stop here and let's open the Q&A session. Maybe I'll hand it over to my colleague Jeroen, who has been monitoring the Q&A so far. Jeroen, I don't know what the status is there.
Yeah, thanks, Christoph. So let's first of all tackle a few questions related to the crop calendars. And for that, I would like to pass on the floor to Italo. So Italo, we have a question for clarification on what type of input data was again used to derive these crop calendars. So only ERA 5 or also optical satellite data. And at the same time, whether this only holds for winter and summer crops, temporary crops, or do you also tackle plantation crops, so perennials?
Yeah, but regarding the first question, the model itself, the machine learning algorithm is only used ERA 5 data. I mean, we use climate parameters, but for increasing the training dataset, we use the MODI CMG product. This is two things. So, and this is only in these areas we have a high percent coverage on the first, based on the first crop calendars that what has been made in WorldCereal Phase I. I hope this can answer. So again, training for modeling purposes, ERA 5, and for increase the training dataset, a remote sensing dataset. And regarding the second question, I will handle carefully because the product has only been trained with annual products regarding, I mean, for grapes, maybe can be more similar the timing of summer crops, but I will take it super carefully because was not trained with this dataset. We only trained it with maize, sorghum, soybeans, sunflower, wheat, barley, millet for summer crops. So I would say it was not be trained with this dataset, so I will handle it carefully, especially when you have different grapes that based on variety can have different evolution of the season.
All right, thanks, Italo. There's one more question related to crop calendars, actually. So the question is the model to compute the start and end of the season, is that model itself available somewhere? Can people use that, or can they only access the crop calendars themselves?
Yeah, the model itself, I mean, the source code is in Zenodo. There is as well a GitHub link that you can access to different source code of the product. So yes, it is as well is keep it updating, but the product and the dataset is available. So as well, if there is like in something, you can contact me. But yeah, if you go to Zenodo link, there is can redirect to GitHub. They can have all the codes.
All right, thank you so much. Then we had one question, I see Christina is already answering that in the chat, related to the sampling training data of crop type maps. So the question was, um, like, how do we deal with other classes, or do we only target specific classes in specific regions? I think there the simple answer is that we simply sample all the available crop types in a given crop type map as long as they match our confidence thresholds that we set up front. But yeah, aside from that, we do not limit sampling to a certain number of crops, or only focus on the crops that are officially to be produced by WorldCereal.
And maybe I just want to add to that also, Jeroen, that we are fully aware of that you're basically, yeah, biasing the amount of data that you sample from those data sets, because you're only going to sample the ones that the maps claim to be certain about. And so very likely the most difficult ones are the ones you're not sampling, but this is a very deliberate choice. In the end, these map-based samples are definitely our preference, are definitely not our preference. It's just our only way forward to at least sample usually the bigger major crops in an area, to at least probably also reproduce partially the patterns, the high accuracy or highly confident patterns in those crop type maps. But yeah, we will not target the difficult and small size crops of those maps, and that is on purpose, because it's better to not feed any very noisy labels and reproduce possible mistakes that are, or uncertainties that are present in the maps.
Maybe related to that, we've seen a few questions about 11 crop types that are to be included in the global WorldCereal products, and whether they can be extended. So indeed, the global products to be produced by end of 2026, so by end of next year, will only be covering 11 standard crop types. But you are free to play around with our processing system to map whatever crop type you have data for. So our processing system is by no means limited to the crop types that we've been showing here today. You are free to experiment yourself and map more crops.
Then we also had a question about Presto WorldCereal pre-trained model, and that it is trained on the satellite embeddings that you mentioned, and if that data set is published. So just to clarify, most of the data that we have, the reference data, or at least a fairly big amount of it, is publicly available. So you can access the reference data itself, which is the geolocation, the validity time, and the label. And next to that, for the publicly available ones, we also already took care of all the satellite data extractions. This is at the pixel scale, or at least the ones that we provide are at the pixel scale. So for all these public data sets, we have the satellite and meteorological time series extractions already available. We offer these through GeoParquet files, which are hosted on a public S3 bucket. If you are using any of our demo notebooks, you will have all these convenience methods that allow you to draw areas of interest And based on that, you're going to send a DuckDB query to that bucket, and it will return you a nice pandas geodata frame with all the original extractions, so the satellite data extractions and the matching labels from that public data. These are not the embeddings yet. So this is really the pre-processed satellite data following our pre-processing convention. So this is monthly composited. That's the usual time granularity that Presto also uses. But other than that, it's the original Sentinel-2 bands, the original Sentinel-1 bands, its precipitation and temperature. So the notebooks themselves then allow to compute based on those time series the embeddings by either taking one of the two versions of the Presto model that we currently have fine-tuned. One is fine-tuned to give you embeddings that can be used for land cover classification. We use those to map crops versus the other land covers. But in principle, you can use that to also train a custom land cover classification algorithm. And on the other hand, we have a version of the model that was fine-tuned on a very rich crop type nomenclature. And so those embeddings really are supposed to contain as much as possible the information that is purely relevant for crop type distinction. So we are supposed to work in a two-stage approach where we first map out cropland, and then within cropland we have these very dedicated embeddings that just distinguish between individual crop types. These embeddings are computed with Presto in a fairly lightweight manner. That's one of the reasons also why we went for Presto. It's extremely lightweight. We run that on the fly in a notebook just on CPU. So even with hundreds of thousands of samples within a notebook, in a few minutes you have all these embeddings just at your fingertips. And the interesting thing about computing them live is that it allows you to position the growing season just as you think it should be. So we don't pre-compute these embeddings because we want you to have full flexibility in playing with this seasonality. If you compare, for example, to Alpha Earth embeddings from Google, these are calendar year based. And so in principle, if you're looking for a crop type that spans a calendar year, you already should have to combine or would have to combine 2 years of Alpha Earth embeddings to have the full information of the crop that is growing across a calendar year. So we want to be flexible in that and allow you to compute these embeddings following your season convention that you think fits best the situation in your area of interest.
All right, great. Thanks, Christoph. In the meantime, we have a few more questions. So first one is on how to deal with small-sized plots with mixed horticultural crops because they're quite challenging to map. I do agree. That's one of the biggest challenges, I believe, the mixed cropping and how to deal with that. So I would recommend in that case, if you're really interested, to collect as much reference data as you can get on that particular situation, add that reference data to the WorldCereal reference data module, and then you can use that data to train basically your own crop identification model specifically fine-tuned for these mixed horticultural crops. So I would really encourage you to treat it as a separate crop type in our classification workflows. Then there was another question on can you use training data from previous seasons to predict crop types in the current season? So yes, we actually highly encourage people to combine training data of multiple years when you construct your crop type identification models to predict crop types for the current model. Clarification though, WorldCereal by default is an end of season crop type classification system, so no in-season capabilities are available as of yet. There was a question on how can others get involved? What if I have a lot of reference data on my country and I notice that it isn't there yet? So we do organize quite a bit of events, capacity building events, training events in different locations. You can, however, well, the best way actually to get involved is just try out the system, as Christoph highlighted at the very last part of the webinar. So just give it a try. Upload your reference data to our reference data module. You have you have the possibility there to share it just with us as a consortium or make it fully public so that everyone can make use of that to train their custom models. So I highly encourage you to just give it a try.
And then we have a question on in-season crop type classification, if that is possible on this platform. In principle, not directly. So it's not part of the current requirements of the WorldCereal system, so to say. Although we know already from the very start in 2019 that this is the biggest request from users. So we did, like I mentioned in the presentation, already a prototype investigation on this, and with the necessary adaptations to the system, which basically boils down to making the models and definitely Presto aware of having highly informative embeddings if you mask out parts of the season. Then we were able to successfully show that you can actually produce an in-season crop type map, provided, of course, that you are sufficiently far into the growing season that at least from a satellite perspective, it can be expected that some of the crops can be distinguished. We saw, for example, in the experiment in France, that the winter cereals were to be distinguished earlier in the season already compared to the other crops, the summer crops that followed a bit later. So I think if you are very handy with code, it should in principle already possible with the tools that you have now to do something like that. And I would definitely hope that at some point we can officially build it into the system in a much more convenient way. But at the moment, for the current tool set as it is, this is not yet planned. So hopefully soon, but not for now. With that, we mark the hour. So thank you for all the questions. If there's any follow-up questions, don't hesitate to let us know. The forum would be the best way to get in touch. There's also a contact form on the website. And yeah, feel free once again to subscribe in the newsletter and to follow us on LinkedIn for all the latest updates. For now, I thank you for your participation, for being here, and for all your questions. And we wish you all a very nice rest of the day. Bye-bye.